right, that may be our cue to get going here. Well, welcome everyone. I think I have the honor of having the coolest panel in the Innovation Summit, speaking modestly. So this is the panel on AI and innovation. My name is Jeff Brock. I'm the Dean of the School of Engineering and Applied Science. And I think we'll have a lively discussion here today with our very heterogeneous, multidisciplinary group of esteemed faculty leaders here at Yale. We'll talk about AI and innovation. So just to sort of set the stage a little bit, I'd like to kind of lean on the notion of innovation. We have kind of a, when you say words enough times, they kind of lose what they mean. So innovation, yes, is something that we do in the context of entrepreneurship and, ecosystem building, but this is really something that is across the research enterprise and certainly across the teaching enterprise here at the university. So, how to understand things anew, how to see newness and novel solutions to things as the goal, and how we can build them. That's the engineering part. I'd also love to keep in our minds the idea of risk, what it means to take risks as a sort of a faculty culture in some sense, or as a university culture. There's a sort of inherent risk aversion. When students work very hard and take their SATs and apply and get into Yale, they've done everything right? So why would they change it? So what does it mean for us to foster a culture of risk at a university? We speak of de-risking innovation, of safe spaces for innovation. How do we do that? And then there's AI, the hot topic. Limitless promises made, a techno-utopian future boldly envisioned and prophesied by our Silicon Valley cognoscenti, with many stunning breakthroughs achieved, but with a lingering question hanging in the air in my mind. If AI is trained on existing data, how can we truly be innovating simply by calculating a probability distribution over known facts, however vast or multidimensional? So how can AI help us innovate? Is it simply an innovator's tool? Can it generate new insights? Will it make our lives better, simpler? So, rather than doing intros for my panelists here, I'd love for them to self-introduce, and I hope they'll reference the way that AI drives their work a bit in their intro. And I have some questions to tease deeper and dig deeper into what they do. Go ahead, Matt.
My name is Matthew Suttor. You can hear me okay?
Yeah. Now you can hear me. Matthew Suttor. I am Program Manager at the Center for Collaborative Arts and Media and also faculty in Theatre, Dance and Performance Studies. The CCAM, as we call it, is an arts-forward creativity and technology center that is open to all staff and students and faculty here at Yale. And we're particularly interested in science, arts, questions, and dialogue. So the reason why I'm sitting here talking to you is way back in 2019, I was introduced to a company in San Francisco called OpenAI. No one had heard of them. A colleague in the School of Medicine said, you need to talk to these people. So I am composing, or am fairly deep into composing an opera about Alan Turing. And so what we did is we were able to have a conversation directly with OpenAI on the training of an instance of GPT here at Yale. And we trained it on Turing's papers. So I went to King's College, Cambridge, looked at his writing, and then the pandemic hit. Yay. Good timing, because it meant that we could have lots of Zoom calls with OpenAI. And we trained it, fine-tuned it, and then we flipped the tables around and asked the instance the same questions that Turing had been asking. Can machines think? Can computers think? We also trained it on plays that we knew that he loved, particularly George Bernard Shaw, books that he had read about science as a child. And the idea is that we would develop a libretto in collaboration with this AI. So the piece, in some sense, is a Turing test. We ourselves, at this point, are confused as to what did we write and what came from the computer. So interesting. Looking forward to your questions.
Go ahead, Shreya.
Hi, I'm Shreya Saxena. I'm an assistant professor in the Department of Biomedical Engineering and the Wittenstein Institute here at Yale in the Center for Neurocomputation and Machine Intelligence. The Wittenstein Institute, for those of you who don't know it, is a pretty new institute with the mission of furthering human cognition. And specifically, my research deals with neuro AI, so the interface between neuroscience and artificial intelligence. My lab focuses on artificial intelligence research to understand the brain better, but also using these principles to actually further the development of AI methodologies. For example, the origins of AI are actually in neuroscience. So taking these principles and building better methods is a big part of what we do. That's a small intro, and I'm also looking forward to your questions.
Hi, I'm Scott Shapiro, and I teach at Yale Law School. In collaboration with the Yale computer scientist Rushka Piskach, we've built a tool that uses AI for legal reasoning. Our law bots take legal questions, and we use LLMs, large language models, to translate them into logical formalism, and then we use logic solvers to answer those questions. Now, this kind of technology would have been unimaginable even a couple of years ago. Actually, when I was a grad student, I tried to do this stuff, and of course, it was not possible. But now, with advances in AI and also actually collaboration with Yale Engineering, our tool is able to empower users, ordinary citizens, to figure out what their legal obligations are and how the law affects them. We like to think about this as the democratization of legal reasoning. Thank you.
Hello, everyone. My name is Marynel Vásquez. I'm an assistant professor in the computer science department, and I work in human-robot interaction. And so we care about how robots may interact with people in the future across a variety of application domains. Now, why is AI important here? Well, first and foremost, we need both social and embodied intelligence to make these robots work by themselves. And so that's a lot of what we tend to think about these days. Just to give you an example, recently we have a lot of projects focusing on how do we align robot behavior with what people actually want. And as you can imagine, there's a lot of very practical applications for this. And so a lot of the actual funding for this type of projects is actually coming from industry. So for instance, we've been collaborating with Google, Meta, the Tata Group on this type of problems. Now, to give you another example, we now have a new project thinking about fairness. What does it mean to have a robot that acts fairly when there's a group of people that it's interacting with? Now, this may seem very simple. Maybe you should do the same for everybody. But there's lots of nuances that actually come into play when you start thinking about, well, should a robot do this or do that? And so we're trying to kind of encode that into algorithms that can hopefully make the robot behave in a way that people do want. Last but not least, I wanted to mention one project that we've been working in collaboration with the Social Robotics Lab here at Yale. This is a project with Brian Scasolati, and the main goal here is to build a robot that can help people with anxiety. And you may wonder, well, how do you do that? Well, one of the first things that people are taught when they have anxiety is to breathe. Have you heard about breathing exercises? Well, this robot is supposed to guide you through doing that. And of course, AI can play a big role in making sure that the robot can read what is the person doing so that it can provide sort of feedback that makes sense for that person. This project is also now a collaboration with the medical school, and so it's a very interdisciplinary effort.
Thank you, Marynel. Good afternoon, everyone. I'm Ted Wittenstein. I teach at our Yale Jackson School of Global Affairs, just down the block. It's Yale's newest school, actually, in the past 2 years, since nearly 50 years ago when the School of Management was created. And I direct our International Security Studies program as well as our Schmidt program on artificial intelligence, emerging technologies, and national power, funded by former Google Alphabet chairman Eric Schmidt. It's an effort really to sort of develop greater technical fluency among our policy-oriented students. So they're not going to be the STEM students that are in Marynel's robotics lab, but they need a greater understanding of these tools to appreciate their impact on global affairs and security writ large. So I'm teaching a new kind of year-long course in this area. Our students are looking at the intersection of AI with law of war and conflict, with U.S.-China technology competition, just to name a few areas. Questions of automation as it impacts disinformation in the global security arena. We have some students at our Jackson School who are partnering with computer science as well as School of Management students in my course. They're developing new startups, sort of applying AI tools to look at some global challenges, ranging from commercial satellite analysis for humanitarian relief, to thinking about how to predict or make determinations about places in the world where political violence might take place. So we're looking to sort of use these innovative tools in the global policy discussion. And in addition to that, we're thinking about how AI is impacting the traditional concepts of diplomacy and great power relations. I led a delegation to China and Taiwan over this past spring break, where our students are starting to learn how to engage with Chinese and Taiwanese partners and not always agree by any stretch, but start to engage on diplomacy and the impact of AI on Sino-American and cross-strait relations. So thank you.
Excellent. All right. So exerting moderator's privilege, I have a question that I've been dying to ask each one of these folks. So I'm going to ask it. And of course, others of you can chime in. Maybe what we can do is keep that part as one part of the conversation. And then toward the end of the time, I'm going to open it up and we can, have a freewheeling discussion. All right. So some of you know I'm a jazz musician. Matt, for years we've had this like band in a box, or you can like set the synthesizer to play a rhythm track while you practice your bass. What about AI is different in terms of fostering creativity, improvisation, the musical or creative experience as an interaction with an AI system? How do you see that generating new ideas, new compositions? I mean, this is what you do, I guess. What's the experience of that like?
Yeah. So my dissertation at Columbia was called Playing the Interface. So I'm a composer, as I said before, and my specialty is in computer music. So I became fascinated looking at writing my own algorithms and then having them realized in real time, listening, and then adjusting at the command line, listening, adjusting, listening, adjusting. So it became a jam session. So I'm constantly listening to feedback. So the agency that we have is to reject the result. Right, we don't have to accept what we receive. And then I became fascinated by these incremental adjustments that I could make in terms of rhythm and pitch sets and things like that. And I noticed that this is an inherently creative flow. What we're doing with the current iteration of this technology is we're able to do this in groups in different countries. And so that's a really, particularly with text, that's really exciting. The power in terms of music is, it's not so interesting to sort of press a button and have the algorithm produce a piece of music. That's not interesting to us, or to me. The power of this is, I think, is a mapping question, right? So if you're looking at, so one thing that we did, for example, in this Turing piece, is that we discovered these incredible drawings that Alan Turing had made at the end of his life around morphogenesis. So he took a hard right turn in his research from computer science to biology, looking at essentially the chemical basis for pattern in nature. And everyone was like, why would you do that? But he produced these incredible drawings that they were never published. So what we did is we took them, so it was like looking at the head of a sunflower and looking at the mathematics of that. And you can recreate that and you get these wonderful Fibonacci spirals. What human beings are not great at doing is saying, okay, well, let's map, say, pitch information onto that and then extract harmonies from it. Because the order of magnitude in terms of just planning that out is going to take hours. You can do it really quickly. And we receive these incredible harmonies and these sort of patterns that would come out of this idea, and then we're able to adjust, again, playing the interface. So that command line ChatGPT world that we're in now, where you ask a question, that is similar to 25 years ago in the computer music studio at Columbia University, me typing in. So there's something really creative about that, because it's prompting you to come up with, like, what is the next question? What if we do this? What if we do this? Right? It's impossible almost to get stuck.
And is there sort of like a cognitive task that it enables that would take time? And you mentioned the mapping problem, like that would take a long time to work out by hand. Is it somehow able to spit that out in real? Is that one of the enabling features?
Yeah. Right. So, for example, I noticed that there's a pattern of triads. I was saying, okay, identify all the triads that fit these parameters and draw an ellipse around them. Bang. Write a MIDI file. Bang. And then you can listen to it. So it's speeding up that creativity and that the way in which the human imagination is always running ahead. What if we do this? What if we do this? And that is really exciting, I think.
Okay, so Shreya, one of the complaints I think we hear, and in particular as scientists and engineers, we have is we're used to deterministic computational systems where you understand each step in the algorithm, or even if you don't understand every step, you know someone did, or someone understood each piece of it. A lot of what we're wrestling with now, I think intellectually, is this idea that there's some black box, some indeterminacy in how these things are working. And yet you are the one sitting here telling us you understand something about cognition and how the brain actually does what it's doing relative to these sort of schemas and methods. Do you have a specific insight that you feel like you've achieved, realized, that would point us to what about these systems actually is mirrored in the way the brain is working that relates to cognition?
Yeah, very tough question. I think that's our goal. I will say, like, we are trying to understand AI systems better as well through the lens of how well do they emulate brain function. So that the goal is to understand both systems better through this bidirectional research. Now, it's interesting that even in the AI world, I think people are resorting because of the black box nature of things. So here I'm talking about large, neural nets, for example, trained, or transformers or what have you, trained on very diverse data sets, where you don't really understand what is going on in the units, in each unit. So when you have a situation like that, you can actually compare it to the brain as well. If you record from a single neuron, it's very difficult to tell what its purpose is. If you look at any one unit in a large neural net, it's very difficult to tell what purpose it has in the neural net. And in fact, people in the AI world are also now resorting to techniques that were used in neuroscience, even a couple of decades ago, that they're trying to understand each unit's function. So, for example, in the last week, I think there was Claude AI. There was a Golden Gate Bridge model. I don't know how many of you heard about this, but this company basically put out one of these LLMs, where they tweaked one or a couple of units in this LLM, such that it would respond very directly with Golden Gate Bridge references. So if whatever question you asked it, it would be like, oh yeah, this is related to the Golden Gate Bridge. It was just in love with it. These are the kinds of studies that neuroscientists had also been thinking about in the past to try to understand how the brain works. But I would say, in at least the neuroscience world, the understanding now has shifted to a population level code. It's not just one neuron that is controlling, any single behavior. It is a population of neurons. It's all the regions that are interconnected that lead to some kind of higher level reasoning, cognition, as well as motor control. So I do think these techniques that we are now developing in neuroscience, very much aided by AI, could actually lead back to helping us understand AI systems better as well. The other thing I wanted to mention is that AI systems don't usually, so they tend to be not very robust and not very, they tend to be not very robust in general, or we don't always understand the robustness properties of these systems. And so we can still learn a lot from the brain and how it works and try to emulate those robustness and generalization principles. So that's exactly what we're trying to do. So for example, my lab is starting in the sensory motor control world. So how do we understand how we make movements in a very robust way, and how do we try to emulate those principles and build networks better? Not sure if it answered your question at all, but because cognition is a really tall goal.
Is there one? I mean, so in the motor control space,
yeah.
Do you feel like there's a hope for a first principles model for what's going on?
So we always work from both kinds of principles, top down, bottom up. So top down, you try to figure out what the goals are of the system and build systems that achieve those goals, this function of that brain region, for example. And you also look at the architecture and the sort of structures that we know that the brain has. We look at where the connections are. We try to build those into our networks as well, in hopes that would actually help. But a key thing here is constraints and regularizations. That's what we end up we constrain our neural network models, for example, with the kinds of biologically motivated constraints, for example, energy efficiency or distributed systems. We try to use these principles, and that actually helps us with robustness and generalization. So these biologically motivated principles can actually help with a lot of things we want, positive qualities in networks.
I love these chances to actually ask my faculty questions. So Scott. Oof. All right, so here's what I want to ask you. So I have the experience frequently when I interact with these systems of like that I'm speaking to a graduate student that's trying to impress me but knows almost nothing. So there's kind of this sort of weird, uncanny sense that they know the right words, they can sort of put them in the right sequence, but then like the content is just completely wrong. And maybe there's some domain areas where that's less the case. I mean, I don't know, maybe if you're asking for like how to change the oil in your car or something, it's better at it. But I have this feeling that you're dealing with this head on. I mean, certainly in a space where the answer better be right if you're writing a law bot. So can you just give us a glimpse into how you attack that kind of hallucination problem?
So as I try to sound like I'm answering your question while not. Just so you know, we were not given these questions before. I want to say that. So absolutely. I mean, what's very exciting about generative AI is that it's generative. What's the downside is that sometimes what you generate is unmoored from reality. And what's really interesting is that because generative AI is so exciting and new, everyone is taking Gen AI and using it for everything, even where it doesn't belong. And so I'm a legal philosopher, and I worry a lot about what kinds of techniques go with what kinds of problems. And so in terms of the tool that I had called a lawbot in my introduction, what we try to do, my colleague Ružika Piskač and I try to do, is we try to take the legal question and the legal materials and translate that into a formalism that we know using available techniques is guaranteed to give you the right answer. It's like a calculator. Now, this is a field, which I'm sure you know all about. It's called formal methods, and in particular, automated reasoning. And automated reasoning and formal methods, you might think, is that AI or is that not AI? In some sense, it doesn't matter. What matters is that it's the right sort of technique for the problem at hand. Now, just to say that problems are hard. And one of the great things about being at a university, especially at like a great research institution like Yale, is that it's just not possible for any discipline to like really make headway into solving the problem that you're dealing with. And so collaborating with computer science, collaborating with engineers allows me as a legal philosopher to actually use the right techniques for the right sorts of problems. And so we don't use generative AI to answer questions like, how much tax do you owe? Are you entitled to Social Security benefits? Should you get Section 8 housing? Questions like that, because their precision really matters. Which is not to say that there isn't use for generative AI in law. There are lots of kinds of problems that make sense to use it. I mean, it's funny because like we also train large language models for other types of legal problems. And when you ask it a question, and generally they're very accurate if trained correctly, but when you ask it a question that there's no good answer, they hallucinate, okay? But that is like precisely what lawyers are paid to do. So I would say, what is the line between hallucination and creativity? Maybe, a couple of $100 an hour.
I think that's what graduate students do too. So you're also a closet computer scientist yourself, right? What's your history there?
Yeah, I'm okay. It's very painful to talk about. But yeah, no, I was, so I grew up I was a teenager right when the personal computer came out, TRS-80, Apple II, and I was hooked on it, and I was a computer science major in college. And I actually had a computer company at a time that was so long ago you couldn't make money in computers. And then I worked on theorem proving as a grad student, and then I decided that the real money was to be made in jurisprudence. And so I gave it up, and it was only 2.5 years ago when I met Ružika, and then she told me, oh no, actually, there have been these huge advances in computer science and theorem proving, and it was like being Rip Van Winkle, like, waking up after a couple of decades and like all the things you wanted to have but you couldn't when you were younger now existed. And like now I kind of code all the time, which is so much, in a way, so much better than writing a book, because like when you write a book it takes like 8 years to get an output, whereas when you code, just hit enter.
Okay, Marynel. The technologists would tell us that the real problem with AI isn't the intelligence of the systems, but the intelligence of the humans using the systems. How do you deal with, in your work, the problem that there's a piece of this that you can control, and then a piece that you can't, the human, and that, you know, a few misses on the trial will result in non-adoption or rejection of the technology. I mean, is there a strategy you employ to think about that?
Yeah, so let me say a couple of things. First and foremost, right now, I would say not just in my lab, but across several labs in robotics, there's this thought that maybe we should kind of start from the beginning and embrace failure. Because chances are it's going to happen. And so if you think about it, right, like when you're interacting with another person, what are the odds that you're going to say everything perfectly and do everything 100% the way that, you know, it would be kind of the ideal? You know, maybe I'm nervous and like, I stutter or something. Like this happens all the time, right? Now, turns out people are very forgiving to these things. What you need to do, though, is you want to set expectations at the right level. And this is where kind of the key to designing these systems comes along. And why I think a lot of kind of the public deployments are so difficult is because people have expectations up here, and that's just not what kind of, you know, the people making the systems are shooting for. They're shooting over here. It just happens people are here. And then, well, they try things out and it doesn't quite work like they want. And then expectations, you know, go down here. It's like, oh my God, this is terrible because like it didn't do this crazy thing that I wanted it to do. But who was thinking about that crazy thing, right? And so when we make these systems, on the one hand, if we can, we try to make it clear that they may not be perfect. For a robot, this is actually very easy. You can have the robot say, I make mistakes. And it turns out people are very forgiving to this. Now, this is kind of the first baby step, right, to kind of making sure that you can at least follow on an interaction. The sort of next level to this is you have to start thinking about what do you do if there's a mistake? And so you have to potentially figure out ways to recognize that there was a mistake, and we're actually working on this in my lab. This is a very big question, right? How do you recognize that something went wrong? I'll give you a hint of one way how you can think about that, and that is analyzing people's nonverbal behavior. So, you know, if I say something crazy here and you're like, whoa, probably I can infer that something was off, right? And so similarly, we can start using AI now to recognize this type of reactions. And these reactions, perhaps are not 100% a sure guarantee that the robot did something wrong. But then the robot can ask, hey, did I do something wrong? And so this is, again, something very natural that comes to us as people when we're interacting with other people. Now, the next step to that, right, if you can recognize a mistake happened, now you have to think about what is the best recovery strategy to go about that. And this is, I would say, pretty much open space. People have tried different couple of things, but it's very unclear kind of what is the right thing to do when. And so I'll give you some examples of this. Perhaps the first thing you're thinking about is, well, the robot can say, I'm sorry, I made a mistake. And, you know, maybe that works one time, but maybe you would be like, oh, this robot always makes mistakes. Not really interesting. Turns out that for a lot of robots in non-critical applications, so, you know, things like, for instance, entertainment, actually it pays sometimes off to blame the human. Whoa. And so to give you an example, right? Let's say that the robot says, hi, you know, I'm here, want to interact with me? And the person is like, no, and goes away. It's like, sorry, you look like you wanted to interact with me. And then maybe actually the person comes back and now they do want to interact with the robot, right? Now, you cannot do these things in all applications, right? There's definitely like a context-sensitive consideration here, right? You imagine, you know, this is a robot that is helping a surgeon operate in a medical room. Making a mistake, this is something that you cannot just repair by saying, sorry, I'm sorry, right? That doesn't work. And so you have to be kind of very careful in terms of what you're designing for and what is the end goal. And making sure, kind of like I started with, making sure that those expectations are right, because that's really the key to kind of enabling these interactions and making people really want to try these systems.
That's great. Let's see. So Ted, because we're running a little short on time, I would love to hear from you about, in your work with the Emerging Technologies and National Power Program, how do you deal with it? I mean, we think of AI systems as kind of, we're interacting with the system, we're checking its results, we're deciding whether we like them, we're tuning. But in reality, in a global geopolitical situation, you have different AI systems that are in competition with one another, clearly.
Sure.
How do you approach that? I mean, it seems like such a challenging, multidimensional problem in addition to those of a given system.
The global dimension is central, I think, to really understanding the impact of these tools. And I think the reason for that is that the technologies are inherently dual use, right? So the technology in itself is value neutral. It depends highly on the ethical controls and constraints and safety protocols that you wish to impose on the system, how you build it. Whereas we've seen in the global context that many nations either lack those ethical controls or wish to pursue a wide range of different objectives and how they might utilize those tools, right? So the incredible artistic generation mimicking Turing that Matt is creating, right? That type of information creating content with AI can, on the flip side, be used to create a sophisticated deep fake technology, right? Or to be used in some sort of influence operation in a malicious way, or some of the fundamentals in robotics that are being developed in Marynel's labs, right? Other nations that are pursuing enhanced robotics for defense applications. For instance, if you look at how Russia is trying to deploy semi-autonomous killer drones in Ukraine, right? They are seeking to use those tools for their advantages in ways that are not aligned with our values. So that doesn't mean that this research shouldn't be happening. It's actually the opposite. It means that Yale should be leading the world and being the place where we can design these tools and show how they can be used for good, how they can be deployed with the proper ethical constraints and aligned with all of our values. But the global dimension has to be realized. So as a former diplomat and intelligence professional, I'm always trained to think of some of the worst case scenarios, and we have to be aware that these tools can easily be manipulated. So this is something that I teach and that we think about a lot in class. And so you have to teach students the limitations of these models, also how to undermine them. You have to teach them, how do you break an ethical constraint, or how do you get ChatGPT to jailbreak and say something horrible, not for the purposes of creating something horrible, but teaching our next generation leaders the importance of even further enhancing these types of safety protocols. So the law and policy and governance context in AI is well behind the technology here. So even within national, there's not a U.S. federal law in this area like you start to see developed in the EU with its AI Act, for example. So let alone the global context. There's a few efforts happening. There was just a major AI safety summit meeting in Seoul, Korea, which notably does have Chinese participation in it. But we are well far off from any sort of global law and norms on this technology. So it's really, I think, incumbent upon professors to engage their students and teach them the ethical and moral compass on how to deploy these tools for positive impact.
Okay, so that's a very natural segue to a general question I had sort of for all of you. We speak sometimes about the perils of the massive energy consumption of training large language models, but there's another kind of massive energy consumption that comes when you have sort of the output of a ChatGPT query, and then you try to decode it and understand it and actually turn it into something you'd be willing to print, for example. So there's this sort of what you're describing where we're supposed to kind of make sure that things are done properly or meet norms of educational practice or society. There's a lot of work that goes into that, right? That's like human work. So, I was speaking to a writer who said she's increasingly getting submissions that like, oh yeah, I ran this in ChatGPT and it's a mess. Can you help me fix it? So that's her work practice is becoming editing ChatGPT output. So what do we do about this as an academic institution? How do we sort of mitigate or think about this huge energy consuming beast we've unleashed on ourselves? I don't know. Go nuts. Who wants to start?
Well, I think it was Scott who referenced the calculator, and I actually kind of like this sort of analogy to ChatGPT of being kind of a calculator for words, right? So it's sort of making probabilistic numerical calculations about word sequences without real knowledge internally about what the output really means, and again at a probability, so not a level of certainty or fact. So it's very important, I think, to think of how our students can use the tool. I do think the future is partnering with AI tools. We can't just entirely pretend that these tools don't exist. And I think we need to train them how to use the tool, but engage in the higher level reasoning, right? So when the calculator came out, Dean Brock's a mathematician, when the calculator came out, we thought it would destroy our education in math, right? But instead what we learned later on, right, was that, the calculator actually enables a huge level of mathematical reasoning, computing, coding that was not possible before, right? So we need to sort of think about, I think, as educators on how to ask the right questions that will allow students to do that second level reasoning using the tool. And again, I'm not sure we've gotten there yet, but it's definitely something I think we have to be very aware of and make them use the tool for a second, third level, fourth level reasoning that the tool itself can't produce on its own.
To follow up on that, I like the calculator analogy. When I was growing up, in India, and we used to have to learn, multiplication tables by rote, just on end. And my parents actually did it really well, so they tried to get me to do it really well. I was like, "What's the point?" but that kind of sort of training helps you, in the end, try to kind of, if the calculator is messing up, if it's giving you random numbers instead, you would be able to tell because you have an intuition in what the results should be. Now with ChatGPT, that's very difficult sometimes. So I think having checks and balances or training people to have the right kind of intuitions, at least about the answers, is really important. And I don't know how to get there in terms of teaching specifically. So we have all learned sort of how to have those intuitions based on our training. But with these kinds of tools, I do agree enabling these tools to be a better part, more integrated with our lives and helping us out in the end is a great goal. But I think building intuition somehow to understand when these tools are wrong is very important, and it's unclear to me how to get there.
Anyone else?
Well, having spent a good couple of years in collaboration with various instances of GPT, the exercise has become one of asking a better question. And we're constantly refining what it is that we're asking, and and also we've also been asking, are you a collaborator? No, I'm not a collaborator. It denies this, which is adorable. But what we've ended up with in terms of this creative exploration is we've ended up in places that we would never have been able to get to otherwise. These certain phrases that come out, being able to say, for example, describe Alan Turing's study in the style of Borges, and then have really kind of a remarkable response, and that just becomes material that we come back to and dissect. So it's been an incredibly rich and rewarding collaborative process that has held us together for years. I'm not sure that would have happened if we were just sitting in a writer's room. And also across space, and we're able to work asynchronously. We're also able to work together in a team on Zoom calls with people in Paris and Ireland and West Coast, Canada, all over the US. So I think in terms of being able to keep essentially a kind of research group together has been incredibly powerful and interesting.
I would just want to say that I think people haven't appreciated how unbelievably useful ChatGPT is for learning. So I didn't know how to train large language models in the beginning of February. Now I'm pretty good at it. Why? Because I would read a technical paper and I would get to a sentence that I didn't understand, and then normally I would be stuck. I just cut and paste it, put in ChatGPT and say, explain it to me like I was in high school. Or this, I keep on getting this error. Tell me why. Explain it to me. And like I feel like ChatGPT is the world's best TA. Like a TA, you could ask questions, doesn't get mad at you. You can ask at 3 a.m. It's so funny because lots of times, like when I really don't understand, I start becoming obsequious. Like, can you please explain to me again why this isn't, what the difference between a projection and transformation is? So I actually think that AI is like amazing for learning about AI. If you want to learn about AI and how to do it, you should use it. And you would be amazed on how quickly you can advance in almost any topic. So, I mean, with the exception, I think, of like learning how to play a musical instrument.
All right, that one's still off limits for now. Any other thoughts, or are there questions from the audience? Yeah, over here.
So I'm not sure it's a question now that a comment, because it's coming from Edward's commentary on, how do we treat it in the education space. So I'm speaking as a founder of an independent school serving late elementary to upper middle school students, and almost terrified of introducing or bringing up AI in that space, but understanding that they need to be prepared in the culture that we live in to, like you said, engage with it and make it a part of the lifestyle. So my question was going to be to some of the most brilliant educators in the world, what should we be teaching them now? So I hear you all saying we're not quite sure. I guess maybe now the question is, as you all begin to explore, I'd like to be a part of that think tank maybe. And I can say what I am doing in my space is looking at the learning best practices in terms of critical thinking and how to teach that. And one of the most important things I learned about that is that we need to teach critical thinking within the subject that you're talking about. So even changing how we think about critical thinking. It's not a boxed situation. If you're talking about social studies, there's a different set of tools and strategies needed as, compared in contrast to science. So just teaching the critical thinking skills, I think using it as to inquiry, teaching them how to use it to inquire about the concepts that they're learning, and really getting a handle on how do we do this now, because there's also the issue of the students coming to you all unprepared and the basic and the fundamentals that are needed. So I want to look at this early as the pipeline to college, in contrast to a pipeline to prison.
Any thoughts about that, Marynel?
So I want to add 2 things. One is you can use AI to learn about any subject. So that's one way to think about education in the context that you're talking about. I think the risk is that perhaps, however you use the AI model, it may give you the wrong answer, and then kids may learn the wrong thing, which seems particularly bad, especially if they're very young, right? What I would say the main association of artificial intelligence, AAAI, has suggested is actually develop a curriculum where you teach children about computer science. How do computers abstract information first? And then you start building from there all the way to what machine learning is, which can then kind of naturally bring you to models like ChatGPT and other things. And so my main suggestion, sort of, knowing about computer science, is to not kind of jump to like having kids in first grade using ChatGPT. I mean, they might try, want to explore it, but that I don't think it's going to be particularly useful from an educational perspective. I think it's better to kind of learn the fundamentals first about what is this computer doing? What is it? How is it representing information? What does it mean? Like, what is an image? Like you see images in your computer all the time. Do you even know what does that look like for the computer? Like these are ideas, right? That I think if we put that into kids' brains first, and then with that understanding, eventually bring them to these models, then I think it's going to be much easier to teach that critical thinking that you're talking about. And so if you have questions about this curriculum, I can send you, the reference to kind of the what they have designed for schools, and you can follow that as a guideline.
As each of you have talked, as each of you have talked about AI and the use and the boundaries. We started to talk a little bit about the boundaries, and it's not clear to me whether we have to do self-policing. Do we need to teach the model to or get OpenAI to do something so you can't go down the wrong path? Or do we end up being regulated in this kind of, like maybe the EU is perhaps going? It's not clear to me, but we've got to start soon, and we've got to figure out what that right roadmap is.
Somewhat related to what you're talking about, but in response to the question about education, this is difficult. So I teach a class called Creativity. And we were a little suspicious of our students generating reading responses using ChatGPT. So we just simply said, you have to be honest. If you're going to be using it, it's a class about creativity, so front up. Okay. But I think from a practice point of view, something that I think that is teachable and is valuable and certainly has been interesting and productive for us is where in the process are you using it? So there's a big difference between generate an idea for me and then you do something as opposed to here's a data set, I'm looking at it a particular way. What if I use AI to do a particular kind of mapping and then listen to the result or look at the result? That's quite a different proposition, and that's a teachable thing. That's an interesting process, I think. So so the students have to make a decision about where and when they use it and how they use it, as opposed to I'm going to use it so I don't have to do the work. It's different.
Yeah, I also wanted to add to potentially the last question as well, that one important skill to teach is probably the fact-checking of, the answers right now do have some source information, like where they actually got it from, depending on which model you're using and which sort of service you're using, teaching people to actually look at that and see how it relates to the answer that the model's spitting out is really helpful.
Ted, did you have
just on the question about sort of the regulatory framework in the United States, without a doubt, tech companies at the moment are in the lead in sort of setting what their own internal regulatory frameworks will look like, absent any kind of federal bipartisan legislation, which seems pretty unlikely at the moment, although Senator Schumer has been leading an effort in this regard. I think one of the real challenges here, if you look at the Biden administration's recent executive order on AI, is that it's asking the companies to sort of voluntarily comply with a set of kind of general core principles and try to create a culture that is based on sort of data privacy, rigorous third-party audits of models and how they are works, red team testing that is then disclosed if you're doing government contracting and work, which most of these companies are, and sort of defining what they're calling frontier models or frontier companies, which is really only about 6 or 7 companies in the United States with huge enough data and energy capacity to really generate massive AI breakthroughs at the frontier. So it's not clear what's going to win out, whether this kind of relatively laissez-faire approach in the US versus a much more regulated framework in the EU that's sort of trying to define human automated decision-making categories, humans that should be in the loop for certain types of decisions. We don't yet know which of these approaches is going to work. Now, the benefit of the laissez-faire approach is that you get kind of breakthrough innovations and experiments and crowdsourcing of new GPT X's that you might never have be allowed at scale in the EU or in other contexts. The downside is that in the race to market, we're sort of deploying these tools as quickly as we can and competing in a way that might give short shrift to ethics and safety and other controls. So you're defining the problem correctly, and I don't know yet which of these approaches is going to win out.
The follow-up is you take it down to the company level, right? And do you give the people the power to do what they want, or do you restrict them and only certain people can do it, or you can only do certain things? And so where's that line, and where is it going to be most effective for the company?
Can I say what a weird moment we're in? Because the normal trajectory of new technologies and the regulation of them is new technologies introduced, the car, the internet, and everyone's private enterprise is allowed to act in an unregulated way for decades until very bad things happen, and then something happens, and then there's a unsafe at any speed Ralph Nader kind of thing. Then you have something like Cambridge Analytica, 2016, and so people start saying, "Oh, maybe we need to regulate it." AI is one of the only instances I can remember, I can think of, where we don't even know how we're going to use it, and people want to regulate it. And this is I'm like very far from a libertarian, but I would just simply say that so much of AI safety and call for AI regulation is window dressing. It doesn't actually make any sense, and it doesn't make any sense because lots of times it's just there to be seen that they're doing things, but also we really don't know what the use cases are. Like, the thing was invented yesterday.
Certainly the powerful thing that we're seeing. I'm afraid we are due in the other part of the house for the awards ceremony, so I may have to leave it there. But I just want to say what a true and deep pleasure it is to have this amazing group of people and to be able to have this conversation with them and with all of you. Thank you very much for coming.